Hello everyone. Welcome. We're doing factoring, GCF, and grouping. Um, just a couple things before we get into this. Factors, we use it to simplify and solve to find terms that are multiplied to get expressions. And then a GCF is always the first step. Our greatest common factor is what you're trying to find. You check your work again by distributing to make sure you get back to the original polynomial. Everything that we do in this unit, you're always going to try and revert to, can I factor out a GCF? That, I think, will save you a lot of time. So go ahead right now. This is a chance to pause the video and try some of these problems on your own, especially those of you that have seen this information before. And then when you're done, go ahead and unpause the video, come back to it, and then check your work. All right, so example number 1 here, for those of you that are ready to kind of move with me, if you take a look, we've got an a of 2 and an m, and an a of 4 and an m squared. We're going to end up taking out an a of 2. Let's see if there it is. And an m out front as my greatest common factors, and we'll be left with 5 minus a squared m. On the second one, 6, 18, and 24, all divisible by 6. Our x cubed is our greatest common factor with our variables, and our y squared is our greatest common factor with our y variable. We'll then take a look and subtract off what we have remaining. So x squared y to the 6th minus 3 plus 4 x to the 3rd y squared. Example 3, you'll now see that they both have a t plus 1. So we'll actually take and pull the entire quantity of t plus 1 out front, and we'll be left with r plus s. In a problem such as this, where you see x minus 1 and then 1 minus x, it might be a good thing to first see if we can somehow maneuver those to both be the same, because they are pretty close to each other. Apologize, my pen is kind of working when it wants to. So I'm going to rewrite the x, 2x times x minus 1. And then I'm going to actually flip this so you can kind of see what it looks like. So plus 4 and then negative x plus 1. Because our signs are different here and here, I'm actually going to pull a negative out. So I'm going to have 2x times x minus 1 minus 4 times x minus 1. I'll then end up with x minus 1 that is out front, and then I'll have 2x minus 4. From here, a 2 can be pulled out of the 2x minus 4. We pull that to the front of the equation, and we'll have 2 times x minus 1 times x minus 2. You can take a shortcut if you can see that these two quantities are flipped. Then the sign will automatically change for your middle, and then you can go ahead and go through your factoring. Okay. Again, that's if you see it. If you don't see it right away, you can always write out the work. That's totally okay. Factor by grouping. This is grouping terms together and using GCF with 4 terms. So if you take a look at example 4, okay, very similar, examples 3 and example 4, to what you're kind of going to do with factor by grouping. We're going to kind of work with grouping the terms in sets of two sets, factor each pair by taking out a GCF, and then rewrite the GCF, and what is left is 2 binomials. So in example 5, you notice that I have 4 terms. So I'm going to group the first 2 terms and group the second 2 terms. Note the sign that's in the middle goes with the last 2 terms. I'm then going to find my greatest common factor within my first 2 terms, which is going to be x squared. I'll then have x plus 3 left. In here, I've got negative 2 that can come out. I'll be left with x plus 3. Notice how inside of our parentheses, these are the same exact thing. That's exactly what we want, because now those are GCFs of x squared and negative 2. So I can now pull the x plus 3 out front. Very similar to what I did in example 3. This is actually almost the same identical step for example 3 and 4 that you started with. We just had one extra step. And then the x squared minus 2. We are not solving, we are just finding factors. So this is going to be our solution. Right. Again, with any of these problems, please make sure to pause the video, try some on your own once you've got it down, and then come back and unpause the video. All right, so for example 6, again, I'm going to go ahead and I am going to pull out my GCFs for my first 2. So it looks like it's going to be 4x. So then I have 3y minus 7. And then negative 5. So I have 3y minus 7. 3y minus 7 times 4x minus 5. Anytime that middle term, that third term, has a negative to it, chances are you'll probably pull out a negative in your problem. All right, and our last example here, you can find a GCF first. I'm going to show you, if you don't, just what kind of happens, which is totally fine. You just have to make sure at the very end that you do end up pulling out a GCF. If my pen works. Here we go. All right, so this first 2 terms, last 2 terms, looks like 2y. 2y. So then x squared minus 2a squared. And I can pull out a 2z. So then I have x squared minus 2a squared. So these are my 2 greatest common factors. So my x squared minus 2a squared. And then I have 2y plus 2z. Now again, I said that whenever you do this, you have to make sure that you don't have anything else that you have to factor out. If you would have pulled a 2 out beforehand, then the 2 would have gone out front to begin with. But in case you forget, which I know a lot of students tend to do, you can pull out the GCF at the very end. Apologize, not sure what's going on with my pen. So 2x squared minus 2a squared times y plus z. That'll be my final answer. Right. Double check your syllabus, make sure you do the correct homework that's associated with this, and I will see you in class.